Okay, welcome everybody. We'll go ahead and get started today. Thank you so much for joining us today at your lunch hour for the Engineering and Operations Management Lunch and Learn webinar series. My name is Karen Hickenbotham. I'll be moderating today. We're in the College of Engineering and Industrial Engineering programs. We offer a Master of Science in Operations Management, Engineering Management, and Engineering. And we also offer 3 graduate certificates in Project Management, Lean Six Sigma, and Homeland Security, which we can touch on later if anybody has any questions on, okay? So again, welcome. I'm in Marketing Communications for the Master of Science in Operations Management and the Engineering Management graduate programs. We ask that you save all your questions until the end of the presentation. We will have an interactive session with our presenter, and we'll announce that about mid-presentation. And we also ask you if you please keep your microphones muted until the end of the presentation. If you rather ask a question in person, that'd be fine too. Just we ask if you wait till the end. Thank you. Those questions will be typed in the chat box. We also want to let our participants know that this webinar is being recorded and it will be posted on ScholarWorks at UARC and our Operations Management collection of our presentations. So again, thank you. Let's go ahead and get started. Our presentation today is Hidden in Plain Sight: Why Sustainment is so important to the circular supply chain for technical products. Our presenter today is Dr. Dave Peterson. He is a senior supply chain management, operations research, and modeling and simulation researcher and practitioner. He specializes in spare parts inventory management and process improvement within the aerospace and defense industry. He's a retired U.S. Air Force logistician, I can't say that word today, with experience in base and depot level supply and maintenance management, graduate logistics education, and policy analysis project management at the senior staff level. After leaving the military, he was an associate professor at Lynchburg College's School of Business and Economics. Most recently, he advises governmental, aerospace, and defense clients on supply chain and operational analytics projects, and also is an instructor in our MSOM program. So we welcome Dr. Dave Peterson. I'm going to go ahead and hand it over to him. Dave, welcome. Thank you.
Okay, thank you, Karen, and good afternoon and welcome to our guests. Appreciate your time. I'd like to start out this presentation with a little story, and it's probably something that is familiar to most of you. Maybe not the exact specifics, but the general situation. And our Prius was well out of warranty when the DV drive in the SAT radio and the nav system failed. So the problem was no radio, no backup camera, no navigation. So I took it to our Toyota dealer, and they pulled the SAT radio nav system from the dash, and we had one option, they said, and that was to replace the entire unit. And at that point, I asked, well, how much would that cost? And they said, oh, around $3,000. And that kind of sent me back a little bit. And I'm doing some quick mental calculations of what a blue book value of a 8-year-old Prius with 150,000 miles might be. And I said, there must be a better way. So went back home and did some internet searches, called around, talked to people, customer service reps, and went to user groups online for Priuses. And I came across this company, United Radio, in East Syracuse, New York. And they specialized in SAT radio nav system repairs. And I called them up and they said that they could replace the DVD drive. And if that was a problem, they'd function test the whole unit and send it back. And it'd be about $500 plus shipping. And I thought, boy, I really would like to have the features, the radio and the navigation and the backup camera. So, it would be worth it. So I took our unit, packaged it up and sent it up to United Radio. And about a week later, they sent it back to me, and I took it down to our Toyota dealer, and they reinstalled it. And, once it was back in the dash and everything was connected, the system immediately booted up and started working perfectly again. And, what I want to point out is that it kind of followed, I can get this to advance, this process. It was a bit of a loop. We pulled the unit failed in operation. We pulled the unit from the dash. We sent it to the repair facility. They fixed it. And then they returned it. And to me, there were a couple morals to this story. And, probably everyone has encountered this type of problem before. Maybe it was a cracked touch screen on a cell phone, or maybe you have an appliance that, is starting to degrade at your home. And what I figured out is that, don't be afraid to look for alternatives and ask around for advice. If the economics and the safety considerations line up, there's nothing wrong with repairing a unit versus replacing it. And the nice thing about United Radio and other professional facilities is they oftentimes warrant their work, so you have some recourse if the problem persists. But, this illustration is just a small example of why sustainment activities are so critical to the circular supply chain. Yet the problem is they often go unnoticed. And the issue is we, meaning consumers and society, need to do a better job of embracing this idea of repairing, not replacing, so that repairing becomes the norm going forward in the future. So fortunately, that's starting to happen today. And there's a rising philosophy called the circular economy. The Earth's resources are limited, and we need to manage those materials wisely. And I'd like to walk through just one product, which would be lithium-ion batteries. And they are a key component for consumer electronics, electric vehicles, and even the energy grid. According to President Biden's June 2021 100-day executive review, Building Resilient Supply Chains, they projected that between 2020 and 2030, that the worldwide use of lithium-ion batteries is going to be increasing by 5 to 7-fold. In fact, as you can see from this chart that came from their study, the greatest increase is going to be in passenger electric vehicles. The key diagrams from this 100-day review is this nice supply chain diagram. And it starts at the top with basically obtaining the raw materials to make the batteries: lithium, ion, cobalt, nickel, and graphite. So those materials right now are primarily retrieved from raw deposits, and then they're sent to a processing facility where they're purified and refined, and then taken to and shipped to another location where they are processed and then incorporated into battery cells, which are then shipped somewhere else to make battery packs, which are then shipped to be incorporated in the final product: electric vehicles, energy grid storage, defense, aviation, and so forth. Well, at some point, those batteries will ultimately wear out, what we call end of life. And then you have to do something with them. And ideally, recycle and reuse them. And what the 100-day report said was that the US needs to increase its domestic battery manufacturing capabilities up and down the supply chain, and also to improve the resilience of this supply chain within our country. Now, why this is important is that they identified the critical problem wasn't necessarily obtaining the raw materials right now, but the bottleneck was in processing and purifying those raw materials. And the report recommended that a leverage point was taking the end-of-life batteries and giving them a second use, in essence, by recycling them and taking that as feedstock back up into higher levels of the supply chain. A related study came out at just about the same time. There's the National Blueprint for Lithium Batteries, which is where this chart came from. And let's just look at the top bar chart. And what you can see is why, an illustration of why it's so important to think about the end-of-life disposition of these batteries. And what they illustrated was that to get the lithium that you need to make batteries in the first place, well, you can distill it from about 750 tons of brine, or you can get around 250 tons of raw ore and refine it, or you can collect 28 tons of spent lithium-ion batteries, and that will also give you 1 ton of battery-grade lithium that you can then reinsert into your supply chain. So what are the benefits of doing this recycling? Well, what the report proposes is that if you can recycle these spent batteries, you'll reduce the production costs by about 40%. You'll reduce the energy needed to generate this raw material feedstock by about 80%. You'll reduce water consumption by about 80%. And you'll also reduce by about 90% the air pollutants. And basically the conclusion was, by developing a circular economy for advanced battery materials, the US can recapture these critical resources, insert them back into the economy, and therefore reduce how much dependence we have on overseas suppliers for the primary materials, plus obtain all sorts of other benefits in terms of economics and environment. You know, so the circular economy idea sounds like a pretty good thing, but let's put it into a little bit more formal definition. And Anne Valentorf and Phil Purnell, who are circular economy researchers at the University of Leeds in the United Kingdom, put together what I think is a pretty good definition, or a working definition for us today. And they said that the idea of a circular economy is pretty simple. First, you want to make better use of your resources. Second, you want to close the loops of your resource flows. And when they say close, they mean once you obtain resources, you don't want to lose those resources. You want to eke out every possible economic advantage you can from them. And the way that you do that is by, recovering the materials instead of wasting them. And if you do a better job of designing the products in the first place in terms of durability and repairability, if you do a better job of designing what materials go into them, you'll be able to keep the products in circulation and in useful, productive life longer. So, it sounds pretty nice. Let's see if we can put that into a more visual presentation. And I'm going to call this kind of the 30,000 foot view of the circular economy. The Ellen MacArthur Foundation is a major circular economy research institute. And they are a proponent of many ideas related to the circular economy, and they often use this diagram to kind of talk about why the circular economy is important. And we'll just take a minute here to walk through it quickly. Down the center of this diagram, if you will, the spine of the diagram, This, you can think of this as like the traditional linear supply chain. At the top, you have the raw resources that are being input into the supply chain: energy, minerals, and they are going into some sort of manufacturing process. And often it's a multi-step process where perhaps, like we saw with the batteries, there's refinement, then you make subcomponents, and then you create other components, and finally you have the end product. So here you're making the parts, making the end product. The product goes to the consumer, the user, and then in the traditional world, when that product reaches its end of life, you have to have some sort of disposal mechanism. And what the MacArthur Foundation is saying is that let's take a little bit broader look at this. And they have, if you will, two sets of cycles on either side of that spine. And on the left is what's called the biological cycle or biosphere. It's basically biological agricultural products and even renewable products like renewable energy from solar or wind. We won't spend too much time on that today. We'll focus mainly on the right-hand side, which are manufactured or technical products. These are consumer goods that we all use in our daily life. And what the MacArthur Foundation's come up with is, if you will, these nested cycles representing how to achieve those guiding principles of the circular economy, closing loops, recovering materials, using less materials. And let's just take a second to walk through this. The first and interior loop is maintaining and prolonging. Think of this as like repairing your car or, getting your cell phone repaired. Something is broken on it. It still has a lot of useful life. You just have to get some repairs done to it. Or maybe you have to upgrade it with new software, something like that. Another cycle is reuse or redistribute. This would be like sharing a product. For example, if you think of like bike shares, if you've ever been to a city where you can rent bikes for the day or rental cars, or you don't necessarily own the product, but you're paying for the use of it. The third cycle is refurbish and remanufacture. And the difference here is primarily a matter of degree. Refurbish is basically making a product serviceable after it's had some usage. Whereas remanufacturing is basically taking that product and making it as good as new. So, refurbishment, think of like if you're getting a car ready to sell, you may do some minor maintenance on it and clean it. Remanufacture, that would be something like rebuilding the transmission or blueprinting the car's engine. And then finally, recycling. And people use the term recycle pretty generically, but you can think of recycling as like repurposing a product, doing reclamation of useful components from that product, or actually recycling, recovering the elemental material value from that product. So again, this is like the 30,000 foot view of the circular economy. So I'm sure you're thinking to yourself, well, the circular economy stuff sounds interesting, but how does it relate to sustainment? Well, the defense sector has been sustaining critical systems like vehicles, ships, and aircraft for many, many years. And I'm going to borrow the definition of sustainment that they use. Sustainment is the provision of logistics and personal resources required to maintain and prolong operations until you successfully accomplish your mission. In some ways, you could think of a sustainment network as a specialized supply chain, a supply chain that's dedicated to keeping critical systems up and running. And importantly, sustainment is actually relevant to all sorts of different civil and commercial systems. For example, information and communication systems, transportation systems, trains, planes, trucks, ships, and the energy grid even. So, this is a great idea, this sustainment, but there is a catch. And that catch is sustainment is not free. In fact, it requires significant investments of time, effort, and money to actually perform sustainment. So how can you justify the expenditures of those resources for doing sustainment? And traditionally, it's been justified in two ways. Either the system that you are sustaining so critical that it's worth you investing in. You can think of like the electrical power grid, or even at your home, getting internet into your house. You're going to spend some money because we all need it. Or just the sheer economics behind it. The supported systems are just so expensive that sustainment is the most affordable way for you to get a return on your capital investment. And that's really true for equipment intensive systems like transportation systems and so forth. So what might a sustainment system network look like? And I'm going to call this the 10,000 foot view. Let's take those previous circular economy cycles. I'm going to just line them up horizontally. So it starts with operating the equipment. It continues with maintaining and prolonging the useful life of that equipment. At some point, you may need to refurbish or remanufacture that equipment or its components. And you may reuse or redistribute that equipment over time. Then finally, there's this disposal. What are you going to do at the end of life? Repurpose it, reclaim it, recycle it. So again, this is a 10,000 foot view. Let's look at what type of logistics activities are underneath the hood of the sustainment network. And, I'll just toss out these 4 examples. There's many other things that you could add in, but to keep each of those cycles going that you just saw, you're going to need elements of supply. Do you have the right repair parts on hand when and where they're needed? Maintenance. Do you have skilled technicians with the proper tools and equipment so that they can fix broken items? Transportation, distribution. Can you move items throughout, back and forth, that sustainment network? And then finally, procurement. Can you identify a source for the repair parts, the equipment, the services that you need to kind of keep that sustainment network running? So let's build a sustainment network, and we'll start at let's say it's a 2,000 foot view now. So we've come down from the 30,000 to the 10,000 to the 2,000 foot view. And we're getting more and more detail. And just, for an example, let's think of a piece of heavy construction equipment like this front end loader. And its sustainment network starts with operating the equipment. And you can see down here, this is our first cycle from that circular economy diagram. So in operating the equipment, the owners, the operators, they're using it. over time, that equipment will incur some sort of wear and tear. And something will break, or it'll need some sort of periodic maintenance, which brings up the second cycle, which is maintain or prolong. Maybe the equipment needs some periodic maintenance based on how many hours you've been operating it, how many miles you've driven it, or maybe just the accrual of minor breaks over time. But what happens is, so this failed equipment will go into our maintenance component, and this is actually, they do several different layers of the cycle. We'll focus on just the yellow part, the kind of the basic equipment maintenance, just enough to get it back and running so that you can return the repaired equipment back to the primary market, the equipment owners and operators. But again, as they're using that equipment, ultimately, especially with these large capital items, something more serious is going to break. And now we're starting to go into our third cycle, which is refurbish and remanufacture, which is in blue. And so now when the failed equipment comes in, instead of minor repairs, it has deeper repairs, refurbish, you're going to restore that equipment to basic serviceability. It may not look like it's brand new, but it works. And that's what many operators need. But some times you'll need to go into the equipment a little bit deeper, and that's remanufacturing, where you really dive into overhauling that equipment and making it as close to new as possible. So in refurbishment or remanufacture, you work on an equipment, it's repaired, and it's again returned back to the use area. But also, in the course of doing that work, sometimes there are components that have to be replaced on that equipment because they failed, they worn out, and they can be sent to a parts refurbishment and remanufacturing facility. And after being, again, refurbished or remanufactured, they'll come out and re-enter the supply chain as serviceable parts. Well, the next cycle, if you remember, was reuse and redistribute. And that's in the kind of purple here. And at some point, especially for capital equipment, the primary owners, primary market owners are going to say, we need a new piece of equipment, has better, newer features, so forth. And so what they do is they will sell their current equipment on the secondary market to owners, operators that that used piece of equipment will be just fine, and so it begins a second life. And those owners are again using it, and they'll go through these different cycles, or maybe from a repair facility, manufacturer's repair facility, they may take trade-ins of equipment. Then they will sell pre-owned equipment on the secondary market. Well, not only major equipment items enter this reuse and redistribute cycle, but components will also do this. So if you remember those serviceable parts that came out of the component level refurbishment and remanufacturing, they may go back in and be folded into making new products, or they may be folded into an inventory, forming a pool of spare parts that these maintenance facilities can draw upon as they're doing the end item repair. And the final cycle is reclaim, repurpose, and recycle. Well, unfortunately, the fact of life is that every manufacturer will ultimately wear out beyond economical repair. And at that point, what do we need to do? Well, we can reclaim salvageable parts and equipment. So we may retire parts and reclaim components from them and re-enter the repair cycle. We may salvage materials, and we may just ultimately recycle. So what I like to do is take a little bit of time here, roll up our sleeves, and walk through some examples of this. And there's going to be a little bit of game, and Karin can explain the rules, but we're going to call it, what type of sustainment activity is this?
That's right, Dave. So we're going to take a little break. We're going to wake everybody up a little bit, get the juices flowing. So we're going to do a brief activity where we're going to ask a series of questions. And the fastest way to do this is to go ahead and type your answer in the chat box. And the first person to type their answer in the chat box with the correct answer will win a swag prize, coffee mug or umbrella. We ask that no staff member is going to be eligible. That is the University of Arkansas or instructors. So those are the only rules to the game. So I'll go ahead and advance. First question is going to be, what type of sustainment activity is this? Is it A, operations, B, reclamation, C, refurbish, or D, repair?
And I'll give you a little hint. These are aircraft at Davis-Monthan Air Force Base. They've been retired. They've been put in restoration or preservation. And these gentlemen are wheeling a wing from it.
Okay, we've got our first answer from Willie Long is reclamation. Is that correct? Reclamation is correct. All right, Willie.
Congratulations.
Congratulations. Again, only one winner per person. And again, no staff members or instructors are eligible. So we'll go ahead and do the next question. Carlos Diaz, thanks for answering. Let's see if we can get the next one. Okay, so what type of sustainment activity would be this? Is it A, reclamation, B, recycle, C, remanufacture, or D, repair?
And the hint here is this is at a Defense Logistics Agency facility. What you see here in gray is a fuselage of a C-130, and it's being mechanically reduced into its elements.
All right, so we've got Carlos and Joseph and Natalia. I think I'm saying that right. Is it Natalia? They say it's all recycled. Carlos was the first to answer. We'll see. B, recycle is correct. So congratulations, Carlos. So let's move on to the next one. What type of sustainment activity is this? Is it A, operations, B, reclamation, C, recycle, D, remanufacture, or E, repair? And I may remind you that there could be more than one answer on one of these.
Okay, I think we have a winner. This is a little bit of a trick question. It's a Amtrak photo, and they're working on a passenger car. But, the photo description was they were doing repair, but remanufacture, it could be, I think you'll see another example in the next slide or two. Okay.
Okay, well, congratulations to Timothy Thornton. He answered that one correctly. Thanks, Tim, for joining us today. Okay, next one is, what type of sustainment activity would this be? Is it A, operations, B, remanufacture, C, repair, or D, repurpose?
This is an old helicopter fuselage. It's no longer flyable, but they're using it for something, practicing firefighting techniques with this fire suppressant foam.
Okay, the answer is going to be D, repurpose. So I believe the winner of that would be Carlos has already won. So we're going to go ahead and go down to our next winner, which is going to be Samantha. I think I am saying that correctly. So D is the answer. Let's see, let's go to the next one. And what type of sustainment activity would this be? Is it A, operations, B, reclamation, C, recycle, D, remanufacture, or E, repair?
And the hint here is that this is a Amtrak train engine, but it's been heavily dismantled.
Okay, let's see. And it's going to be Remanufacture. I don't think I see a winner from that one. I think we have
It's a little tricky to figure out if this is remanufacturing or repair, but the level of detail or depth that they went into probably makes it remanufacturing.
Okay, let's go to the final one. I believe this is the last one. What type of sustainment activity would this be? A, operations, B, reclamation, C, recycle, D, refurbish, or E, repair. And I think,
Okay.
that is a little bit of a tricky one.
Yeah, I had to throw a ringer in there, Karen. Actually, this is a picture of a airman who is doing some pre-winter preparations of their snow removal equipment. You know, it's in the fall and they were doing some work to make sure everything's ready. So we'll take either refurbish or repair. So yeah,
right. That's going to be congratulations to Joseph. Then we'll go ahead and give him that for a win.
I think everyone has done a good job. Don't you think, Karen, picking up on what these different sustainment activities are?
I do. That's pretty good. Pretty good. So we'll let you get on with the rest of the presentation there, Dave. Thanks for that.
Okay. Well, let's tie this all together. And I'm taking some cues from a friend of mine, Deborah Dawes, who published a book, The Circular Supply Chain. And she has this diagram about the different components of circularity. And the first one is circular materials. Materials circulate because they have more value to give. Remember, we want to wring out every ounce of value we can possible from the materials. And then circular operations. Basically, the idea here is that, you know, let's reduce the primary materials that we need and take materials that have already been used before and try to reinsert them into the process, like with those lithium-ion batteries, or even find ways to reduce the materials that you need. And then finally, circular business models. And the circular business model shifts your circular business model from the traditional supply chain to the one with those cycles that we were looking at. So how does sustainment tie into this? Well, first off, your business needs to include sustainment in its strategy. You know, not only figuring out what the customer needs, but ways that you can help extend the product's useful life and give the customer greater value for that item. The next sustainment function is sustainment network operations. And this is where you translate your strategy, however you want to support your customer. You translate it into the daily routine of actually providing those sustainment services to the customer. And finally, the sustainment network structure. And think of this as like, you know, how does a part actually flow from point A to point B, from where it's made to where it's used in your sustainment network? And if you can put together this circularity and the sustainment, what you end up with is actually an actionable circular economy. And this is where I think, you know, we're falling short a little bit in today's world in terms of there's been a lot of study about the theory of circular economy, but not about putting it into practice. So let me just wrap up with 4 key ideas. And first, the key idea is the Earth is running out of resources. We have finite resources. And as we incur more and more resource shortages, it's going to have a direct impact upon maintaining or improving our quality of life. You know, so we really need to think through this. The second key idea, the circular economy philosophy, is directly relevant to supply chains, especially supply chains for technical or manufactured products. People will have talked about this, but they really haven't taken it down to like that 2,000-foot level yet of really rolling up their sleeves and making it work. Third, sustainment networks and practices are all around us. They've been around for a long time, but the problem is they're almost invisible. Unless some part of the sustainment system breaks and fails, like the cold storage of vaccinations recently for coronavirus. Unless there's some sort of challenge, sustainment almost kind of goes unnoticed. And then fourth, we really need to focus more attention on how to carry out circular activities and keeping technical products serviceable. And when I say more attention, I mean in the academic community in terms of research, in the commercial world in terms of companies thinking through their supply chains and their products, and even on the government side in terms of national strategies, like you were seeing those two reports that were mentioned early on in this report or in this presentation. So, well, I think that kind of wraps up what I wanted to cover in our time today, Karen. So let me turn it back over to you.
Okay, well, thank you very much, Dave. Great presentation. I enjoyed doing the run through with you yesterday and learning about this, and I've absorbed even more today. So excellent presentation. Thank you so much. We're going to have a question and answer with Dave real quick. We're going to go ahead and kick it off. And Dave, if you could, I'm wondering, while everyone is kind of formulating their questions in the chat box, we've had a few drop off, so we've got plenty of time for questions if you want to think of something you want to ask Dave. But Dave, I'd like to know what operations management courses in the Master of Science program would cover topics related to the circularity and sustainment.
I think that we're actually pretty lucky in terms of our program because we have several courses that really are relevant to this idea of the circular economy and sustainment networks. And the first one is our operations management course. And really that's kind of the introduction course to things like strategy, forecasting, product design, quality, process design, facilities, their location, their layout, human factors, an intro to the supply chain, and even inventory. So it really is kind of our first blush at the key operation management decisions. And then we have some more specialty courses. We have a supply chain management course, which talks about more detail about things like inventory management, aggregate planning, setting up, designing your supply chain, transportation sourcing, and even things like pricing and that. And we really didn't have time today to talk about the economics. And something that is kind of unique to UARC is that we also have a maintenance management course. And in that course, it talks about, again, things like reliability, an overview of maintenance metrics, equipment maintenance, optimizing your maintenance system, its structure, work planning, measurement and improvement of your measurement of your maintenance system and so forth. So really we have several different courses that all bear upon this subject.
Okay, great. Thank you for that. While we're waiting, again, please type your questions in the chat box. This could be anything from if you're a current student and you're thinking about taking a course, you've got Dr. Peterson here to answer any questions before you maybe sign up for a course, or if you're thinking about maybe a graduate certificate or maybe signing up for or applying for the management of science degree. This is an excellent opportunity to kind of see where you're at in your career, how this would apply to you, or if you're looking for a career change, this really could apply to anybody. So again, feel free to type in any questions in the chat box. But meanwhile, we'll just let you know what we're all about. The Operations Management Master of Science degree is 100% online. It's in-state tuition for everyone with 10 graduate courses that equal 30 hours that also outside may have 4 prerequisite classes outside of that to be required. We offer 5 8-week sessions per year, and you can pair that master's degree with a graduate certificate concurrently without taking any extra hours. Currently, we're waiving the GRE or the GMAT with a required bachelor's of 3.0 or better, with an exception if you have a 2.5 undergraduate as well. Total program cost is anywhere between $10,000 or $15,000, depending on what courses you might need to take. Here are the 3 graduate certificates that I mentioned at the top of the hour. We have Project Management, Lean Six Sigma, and Homeland Security. And with our graduate certificates, they comprise of only 4 classes. Again, you can obtain this either on its own or while you're earning your master's degree. There's a 2.5 GPA requirement for admission. No graduate level scores are required. And this is also an option if you think you might want to just start off with a certificate and then move into the Master of Science program. This is also a way to transition to there. So with the COVID-19 special announcement with the GRE testing centers not in full operations, we are waiving for admissions a 2.5 undergraduate GPA or better. Just to let everyone know before we start dropping off, our next webinar is going to be in October, third-party management and cyber supply chain risk with Gerald Garner. We want to thank you all for attending. I'm still looking at the chat. It doesn't seem like anybody's got any questions. You can always email myself. You can email our staff here at msom@uark.edu. I will be following up with all of the registered participants with the link to this video. If you'd like to share it with colleagues or pass it along to someone who might be interested in the program. And for those who registered who may have to jump off early or not be able to attend today. You can also visit our website at operations-management.uark.edu for any more information on our programs. And so with that, I don't see any other questions. So I want to thank Dr. Dave Peterson very much for taking time out of your busy schedule to present to us today. I certainly learned a lot when I heard about this topic. I actually started reading articles and doing research on my own, and I've learned a lot about the sustainment of our economy and how important this is. So great topic. This is something great to build on, and hopefully we can implement that in more of our courses down the road to help others help their organizations. So thank you, Dr. Peterson.
Thank you very much for the opportunity, Karen. And if anyone wants to continue the discussion about circular economy and sustainment, my email is dkpeters@uark.edu. I'd be happy to follow up on any other discussions, because I just see this area is becoming more and more important as time goes on.
Great. Thank you so much. Again, everyone, enjoy the rest of your day, enjoy the rest of the week, and we hope to see you online next month for our next webinar.